head over to Sarah for a subject near and dear, not just to my heart, but I think everyone's heart, the James Webb Telescope. And I actually worked on that proposal in the 1990s, so over to you, Sarah.
Good morning. Wow, that's very cool, AJ. I did not know that. Yes, we're going to look at some of the amazing images from the James Webb Telescope. I'm going to put our astronomer hats on today. So the James Webb Space Telescope is the largest space telescope made to conduct infrared astronomy. Its high resolution and high sensitivity instruments allow it to view objects that are too old, too distant, or too faint. For example, the Hubble Space Telescope, which we've talked about in a few previous art talks. This enables investigations across many fields of astronomy and cosmology, such as observation of the first stars, the formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. Earlier this month, President Biden remarked on the first preview images released of the telescope. He said, quote, "It's a new window into the history of our universe, and today we are going to get a glimpse of that first light to shine through that window. These images remind the American people, especially our children, that there is nothing beyond our capabilities or possibilities." So this month is the 1-year anniversary of the Webb telescope, and it has produced the deepest and sharpest infrared image of the distant universe to date. Known as Webb's first deep field, this image of a galaxy cluster SMA CS 0723, also known as the Roofyuki cloud complex. It's overflowing with detail. Thousands of galaxies, including the faintest objects ever observed in the infrared, have appeared in Webb's view for the first time. Now, the downside of an infrared telescope is that they have to be kept extremely cold, below 50 Kelvin or negative 370 degrees Fahrenheit. So scientists created a 5-layer sun shield to protect it from heat created by the sun, the earth, and even the moon. So here's a closer look at that image, and we can see just how much detail this image still has, even in the zoomed in version. Again, this is the Roofyuki cloud complex, the closest star-forming region to Earth at 390 light years away. It's a relatively small, kind of quiet stellar nursery, but you'd never know that from looking at this very chaotic close-up. Actually, to the naked eye, this region of the sky looks black, but with the infrared telescope, we can see these vibrant colors that indicate very active star formation. Jets that are bursting from young stars crisscross the image, impacting the surrounding interstellar gas and lighting up the molecular hydrogen, which is shown in red. Some stars display the telltale shadow of a circumstellar disk, which is the makings of future planetary systems. At the moment, the region displays about 50 young stars with the same mass as planet Earth. So very exciting region that scientists are observing. Images from the Webb telescope reveal large amounts of dust within supernova 2004 ET and supernova 2017 EAW. These supernovae are located in the spiral galaxy NGC 6946, which is 22 million light years away from Earth. And the hexagonal shape of supernova 2004 ET on the left is actually a result of the telescope's mirror shape. When a bright light of a point is observed in the mirror, the light interacts with the sharp edges of the telescope, creating these hexagonal diffraction spikes. So dust is a building block for many things in our universe, planets in particular. And as dust from dying stars spreads throughout space, it carries essential elements to give birth to the next generation of stars and their planets. You can kind of think of it like pollen blowing in the wind that will help the nearby flowers grow. So this artist concept portrays the star PDS-70 and its inner protoplanetary disk. New measurements by the telescope have detected water vapor at distances of less than 100 million miles from the star, the region where rocky terrestrial planets may be forming. This is the first detection of water in the terrestrial region of a disk that's already known to host 2 or more protoplanets, one of which you can see in the upper right. These Webb images show a part of the Orion Nebula known as the Orion Bar. The largest image on the left is from Webb's near-infrared camera instrument. At upper right, the telescope is focused on a smaller area using Webb's mid-infrared instrument. And at the center of the mid-infrared area is a young star system with a protoplanetary disk named D203506 The pullout at the bottom right displays a combined near-infrared and mid-infrared image of this young system. Carbon compounds form the foundations of all known life, and as such are particularly interesting to scientists working to understand both how life developed on Earth and how it could potentially develop somewhere else in our universe. The study of interstellar organic chemistry, which Webb is opening in new ways, is an area of keen fascination to many astronomers. So stare deeply in this vast landscape on the left. It was stitched together from multiple images captured by the telescope in near infrared light. There's a lot of activity going on, so I'll kind of describe this a little slower. So to the right of center is a clump of bright white spiral galaxies that seem to be twisting into one another. Threaded throughout the scene are light pink swirls that look like pinwheels twirling in the wind. The bright foreground stars, set off in blue, announce themselves with Webb's prominent 8-pointed diffraction spikes. The graphic on the right shows a graph of the detections of the most distant active supermassive black holes currently known in the universe. They were identified by a range of telescopes, both in space and on the ground. And 3 were recently identified in the James Webb Space Telescope's Cosmic Evolution Early Release Science Survey, also known as SEERS. And we can see that SEERS 2782 is at the far end of this spectrum. So again, this telescope is able to capture things in space that are farther and older than other telescopes have been able to. The Webb telescope is at the beginning of its life and has already identified images that have given scientists and astronomers insights into the past, present, and future of our universe. The primary mission of the telescope is 5.5 years, but the expected lifetime of the Webb Space Telescope is 20 years. So hopefully a lot more will be in store for this newer telescope. Thanks, everyone, and I will see you next week.
Wow, thank you so much, Sarah. Not only did we know that you're a great art historian, but also now I think we're beginning to think you also have a degree in astrophysics and cosmology. Amazing photos, aren't they? Just amazing, even just after one year of operations, right?